Welcome to the Northeastern University Innovation Campus at Burlington, Massachusetts, and the Expeditionary Cyber and Unmanned Aircraft Systems Lab. What we have just entered is a brand new state-of-the-art anechoic chamber in Faraday cage. It's a 50-foot by 50-foot by 22-foot tall structure, purpose-built for doing research on unmanned and autonomous vehicles.
It's a very unique facility in the sense that it's the only facility in the nation that allows you to experiment with systems of unmanned vehicles and unmanned aerial systems, both indoor and outdoor.
Having worked in these facilities before, what was exciting is that we got to build one from the ground up. What's nice about this facility is that the outdoor facility is linked with the indoor facility. So you can seamlessly transition from the outdoors to the indoors. That's a huge advantage for people like me who want to do research.
The fact that there is complete shielding of RF signals in this space allows us to perform very exciting research.
The connection between the hardware and software is much closer. So many of the attacks we study, and as a result, many of the ways in which we try to make things safer, actually have to do with interactions with physical environment. Ground drones, air drones, all that stuff. Those are perfect examples of, you might call, cyber-physical systems, where these physical effects really have a profound effect on the underlying cybersecurity.
For us, having this infrastructure is a way to realistically test the fundamental science in a controlled environment. This facility is helping us to further our research. Having this anechoic chamber, where we have state-of-the-art equipment, help us to characterize the intrinsic uncertainty in our systems. The fact that we can go outdoors and add additional component of variability in order to test the performance of our system is very unique. It really shows industry and federal agencies the work that we are doing here is one step closer to be deployed in the field.
This facility is integral to my research because we need a safe space where we can fly these complex systems without external interference.
This facility has an amazing array of software radios connected to antennas on the ceiling. These are fully programmable, state-of-the-art software radios that can interact with the drones. It has this system of cameras that can track at the millimeter level the position of drones that is, again, state-of-the-art and quite unique. In addition to that, it's an anechoic chamber. It absorbs all the wireless signals, so you can do repeatable experiments, and it's a Faraday cage, so you don't get interference from outside.
We also have the capability to do electromagnetic pulse testing. So we have an area where we would install a generator and a directional antenna that would be used to test the susceptibility of devices to electromagnetic pulses. This is extremely important to make sure that devices can withstand this type of RF interference and this type of situation that they might encounter in the real world. And so we would use this system to test devices and make sure that they are robust against that type of environment. We can do all sorts of different testing with the equipment that we have. We can do GPS denied testing. We can do GPS jamming. We can do wireless testing with different protocols, whether it's LTE or 5G or Wi-Fi. We can do all that with our simulation, with our RF simulation capabilities that we have.
Put all these things together, you get a unique facility in the nation, probably worldwide.
Even though we look at these as individual capabilities, when we take them together as a system, the individual capabilities sum up to something which is much greater than the sum of the individual parts. The entire system associated with this indoor and outdoor facility is what makes it unique.